So today we're going to be talking a little bit about displacement in positions and why you really care about that. So let's start out with displacement, and we're going to define that simply as the distance between the starting and ending points. And ending points. So what we mean by that is that if we have Tom here and he starts with an initial position, and let's say he walks 5 meters, and now Tom's here, then we know that Tom has moved and displaced 5 meters. And we're going to use meters because displacement, or our distance, we like to define in terms of length. And our favorite unit for length is going to be meters. Now, the difference between displacement and distance is simply that displacement is the almost absolute value of distance. So, for instance, if we have Tom again here, and let's say he walks 2 meters this way, and then walks 1 meter backward, and then 2 more meters forward, he's traveled a total distance of 2, 3, 5 meters. But if we look back at displacement, we'll see that the difference between his starting position and his final position is 3 meters. So his displacement is only 3 meters. So we can tell that the distance is the absolute value of total distance traveled. So what that kind of looks like on a graph, and this might help explain it a little better, is we'll use the same example. Let's say in his first meter he walks 2. He then walks backwards 1 meter, and then forward 2 more meters. So the graph of his position looks like that, where he walks forward, backward, and forward, where he has traveled a total distance of 5 meters, but has only displaced a total of 3. The best way to represent this, and we'll define this with delta x, the difference between the initial points, the final position, our final position, minus our initial x position. So we'll do that real quick here. Our final position is 3, minus our initial position 0, is going to give us our displacement of 3 meters.